Introduction to Graphs. Dependent and independent variable. In our day-to-day life, we see many instances where one quantity affects another. You might have observed that the more you use a facility, the more you pay for it. We can consider the example of consumption of water and the water bill. If more water is consumed, the bill is bound to be high. If less water is used, then the bill will be easily manageable. Here, the amount of water bill depends on the quantity of water used. Thus, the quantity of water is an independent variable, and the amount of water bill is the dependent variable. We can see many other instances where one quantity depends on the other. The relation between dependent and independent variable can be shown using linear graphs. Here we'll discuss about dependent and independent variables using graphs for quantity and cost, principal and simple interest, and time and distance. Quantity and cost. When we purchase any item, if the quantity is more, the cost will also be more. So the quantity is the independent variable and the cost is the dependent variable. We will use linear graphs to solve some problems related to quantity and cost. Let's consider an example. The following table gives the quantity of apples and its cost. Let us plot a graph now. We'll consider number of apples along x-axis and cost of apples along the y-axis. We consider a suitable scale as shown here. We can form points by taking x-coordinates as number of apples and y-coordinates as the cost of apples. Then the points are 1, 5, 2, 10, 3, 15, 4, 20, and 5, 25. Now let us plot the points and join them. Observe that the graph is a linear graph. Let us consider another example. The following table gives the quantity of petrol and its cost. Let's plot the graph to show the data. We mark number of liters along the x-axis and the cost of petrol along the y-axis. The points are 10, 500, 15, 750, 20, 1000, and 25, 1250. Now let us plot these points. By joining these points, we get a linear graph. This graph can help us estimate a few things. Suppose we want to find the amount needed to buy 13 liters of petrol. Locate 13 on the horizontal axis. Follow the vertical line through 13 till you meet the graph at P. From P, you take a horizontal line to meet the vertical axis. This meeting point provides the answer. So the cost of 13 liters is rupees 650. Problems on principal and simple interest. Let us now solve problems based on principal and simple interest. A bank gives 10% simple interest (SI) on deposits by senior citizens. We have to draw a graph to illustrate the relation between the sum deposited and the simple interest earned. First, we have to find the quantities to be plotted as deposit and SI. We can calculate simple interest as shown here. Now let us draw a graph for this data. First, we have to decide the quantities to be taken on the x-axis and the y-axis. We'll consider deposits along the x-axis and annual simple interest along the y-axis. We consider a suitable scale as shown here. Now consider the points by taking x-coordinate as deposits and simple interest as y-coordinate. Thus, the points are 100, 10, 200, 20, 300, 30, 500, 50, and 1000, 100. Now we plot these points and join them. What will be the annual interest obtained for an investment of rupees 250? From the graph, it is clear that corresponding to rupees 250 on horizontal axis, we get the interest to be rupees 25 on vertical axis. What is the investment one has to make to get an annual simple interest of rupees 70? Corresponding to rupees 70 on the vertical axis, we get the sum to be rupees 700 on the horizontal axis. Let us consider another example. Interest on deposits for a year is as shown here. To draw the graph, let's consider deposits along the x-axis and annual simple interest along the y-axis. The points are 1000, 80, 2000, 160, 3000, 240, 4000, 320, and 5000, 400. By plotting these points and joining them, we get the required graph. Let us now answer a few questions from the graph. 1. Does the graph pass through the origin? Yes. From the graph, it is clear that the graph is passing through the origin. 2. What is the interest on rupees 2,500 for a year? The interest on rupees 2,500 is rupees 200. 3. To get an interest of rupees 280 per year, how much money should be deposited? Rupees 3,000 should be deposited to get an interest of rupees 280. Problems on time and distance. Let us now solve the problems on time and distance. The distance traveled by a car at different time intervals is given here. The graph of this data is shown here. From the graph, let us answer the following question. How much distance did the car cover during the period 7:30 a.m. to 8 a.m.? At 7:30 a.m., the car has traveled 100 kilometers, and at 8 a.m., the car has traveled 120 kilometers. Thus, during the period 7:30 a.m. to 8 a.m., the distance covered by the car is 20 kilometers. What was the time when the car had covered a distance of 100 kilometers since its start? The car covered a distance of 100 kilometers at 7:30 a.m. since its start. Summary. Let us summarize what we have learned. The relation between an independent and dependent variable can be depicted through a linear graph.